We started seeing permutations a little bit yesterday, and factorial notation. So yesterday we looked at this problem here, but I just want to kind of look at sort of a similar problem to talk about. If you have a situation, so a really common, normal type of, a really common problem involving permutations is just when we're talking about letters in a word. They like doing this, where they'll give you a word with a bunch of letters in it. You know, now they can't have, well, for now anyway. Eventually they will, but for our purposes as of right now, we can't have any repeating letters. Okay, so thinking about the definition of a permutation that we learned yesterday, for right now, since we're just looking at simple permutations, permutation is really just a fancy word for ordering. It means like putting something in a different order. If you look at that definition that's on the slide that we looked at yesterday, why at this point would we not have any repeating letters? Yeah, sure. Jalen's not there. Leon, could you turn off the lights? Okay, so considering the definition we saw the other day, it said, I can't remember exactly what it said, to be honest with you. Something about, can someone read it actually for me? Because I don't have it open. It says it on that slide with the Naomi question. Nobody's brave enough. I know reading's pretty scary. Okay, it's an arrangement of distinguishable objects in a definite order. So the reason that we can't have, at this point, we will see ones that do, but for now that we can't see examples with repeated letters in them is because letters that are the same aren't what? Which word in that definition would it not meet? It's the really long word. Okay, they're not distinguishable. If I had two S's in a word, they're not distinguishable from each other. Okay, you can't tell them apart, the two S's. So, for instance, just to be clear with that, for now we're not going to see these. We will see them eventually. There is a way to deal with it. Okay, but imagine if I had the word access. Okay, the word access has two C's and two S's in it. If I rearranged these letters, if I was just like, okay, if I just rearranged them like this, it's the same letters. Now, the problem with this is I can't tell if this C is the first C or the second C. Okay, there's no way to tell. Okay, I can't tell, did I put this one here and this one here, or did I put that one here and this one here? And it ends up mixing up our definition of what a permutation is. So that's why for now we're not going to see those. There is a way of dealing with those problems, but we won't see it yet. So a really common, easy type of question with permutations is, how many different ways can you rearrange the letters in the word computer? Okay, that would be a really simple question. Okay, so the way you actually solve that question is, for now, is just kind of think about how many letters there are. So there's 8 letters, so I make a space for each of the 8. This is how I do it. I think it out really nice and slow. And I'm like, okay, well, for the first letter in the word, I would have how many options? How many different letters could I put down first? Not 26, because they have to be from computer. There'd be 8 choices. Then I use one of them. So now for the next letter, there's 7 choices. Then 6, then 5, then 4, then 3, then 2, then 1. Now, does anyone remember, and then you just times them together, does anyone remember the fast way, we learned it right at the end of class yesterday, of writing down this long multiplication? That exclamation point. It's called a factorial symbol. I'd love it if people called it that, but I know what you mean if you say exclamation point. Okay, so this is 8 factorial. So you can just enter that into a calculator, it'll give you the answer, it'll tell you what it is, okay, rather than having to type it all the way around. Now, if I gave you a question instead, okay, just to be clear, if I gave you one instead that said, how many different arrangements could I make with the letters from the word computer, but I was asking about a 5-letter arrangement. So if I said, how many 5-letter arrangements can you make? Okay, if I ask that question instead, okay, now if we're trying to make a 5-letter word or arrangement, they don't usually say the word word because word implies that it would have to be an actual word. A lot of these arrangements, most of them in fact, like almost all of them, would not be actual words. So if I was doing that, it would still start the same way. Like if I was trying to make a 5-letter thing, right? Like I could pick like M-O-P-U-T. That would be one. I could pick any 5 letters I want from the word computer. So the first letter still has 8 choices. The second one still is 7. The third one still is 6. The fourth one still is 5. And the fifth one has 4. But I couldn't type in 8 factorial then. Then I'd have to type that in all the way out. Okay? Or there is a slightly faster way, which we would be getting to today. So I would just type that out and get a number, whatever it happens to be. It doesn't really matter. Okay, so these questions with words are really common and really pretty straightforward. There's usually at least one on the departmental, although they often are slightly trickier than really basic ones. They like to put little restrictions on them. They'll be like, the middle letter has to be an M, or something like that. Okay? Oh, goodness, that's scary. Okay, that's never happened to me before. Okay, so 10 factorial, we saw it there on the calculator, whatever it said. Okay. We write down 10, math, go over to probability 4, it's 3,628,800. That's a big number, obviously. Okay? And when we're dealing with factorials, you can expect the numbers to get pretty big pretty fast. Just because we're multiplying, like once you multiply 10 times 9, that's 90, times 8, 720, then we're timesing that by 7, like it's going to get big really quickly. So these ones with the division, if I ask you on a test and I can't see a situation where I would ask you to show work, but generally speaking, really just typing into the calculator is fine. But I want to show you this anyway because once we start doing it, we're going to do it with variables right away, which is obviously harder. Okay, and showing you out the long way makes the variable stuff more intuitive. Okay? It makes it clearer how it works. So when we're doing something like 12 factorial, 9 factorial, I know the answer is 220 or whatever I just got, but if I was doing it out by hand, it actually wouldn't be that bad, believe it or not. Yeah, I know it seems like it would be really bad, but it's actually not that bad because 12 factorial means 12 times 11 times 10 times 9 times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. Now, if I actually tried to do that multiplication, if I actually sat down and was like, okay, 12 times 11 is 132, times 10 is 1320, times 9 is, and I started doing that, that would be really bad. Okay, that would take, obviously, a long time and would be very difficult. Okay, but instead, what I do is I just keep writing it out. So 9 factorial on the bottom is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 9 factorial. And 3 factorial is 3 times 2 times 1. Now what happens is that I have a bunch of stuff on the top multiplying that's the same as a bunch of the stuff on the bottom multiplying. So I can cancel them off. Okay? Basically, everything from 9 downwards, 9, 8, 7, 6, 5, 4, 3, 2, 1, is also on the bottom. So I can cancel them. So I end up with just 12 times 11 times 10 over 3 times 2 times 1. Okay? And that's significantly easier. Right? Everyone's agreeing with me? I think it's easier. Okay, now even this, you could simplify further. What's 3 times 2 times 1? 6. So I could change this from 12 to 12, 11, 10 divided by 6. And then if I wanted to, I could do this division. So 12 divided by 6 is 2. So I could do 2 times 11 times 10. And now that's really easy, because 2 times 11 is 22, and 22 times 10 is 220. So that actually didn't take a ton of brain power. I didn't have to do any really hard multiplications in my head or anything, and it's possible. Of course, it is easier to type it into your calculator. I would not deny that, and I would expect you to type it into your calculator, but like I said, we're about to do this with variables, and with variables, you can't type it into your calculator, because you don't know what x is, or whatever variable we're using, so you'll have to be able to do it somewhat by hand. So think about this process, and what I just did there, and how it worked. I'm going to even talk about it a little bit more, just to make it really clear, because I find students have a little bit of trouble with this part. If you have something like 9 factorial over 5 factorial, okay, these divisions we're going to be dealing with a lot. Okay, so if we have something like this, you can even do it a little bit faster if you want. Like the way if I did it all the way out like I just did, right, I'd have 9 times 5 times, or 9 times 5, that's not right. That's not the order numbers go in. 9 times 8 times 7 times 6. Getting emails. Okay. 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. And a bunch cancels. Same way. So everything from 5 onwards cancels. Now you could do that. Once you kind of get the hang of it, you could do it without having to write all that down. One fast way to do it, or a little bit faster, is instead of writing 9, 8, 7, 6, 5, 4, 3 all the way down, you can just write until you get to the number you want. So I'm like 9 times 8 times 7 times 6. And now that I'm at 5, which is the number that's on the bottom, I could just write 5 factorial. 9 times 8 times 7 times 6 times 5 factorial is the same as 9 factorial. They're equivalent. Okay, so then if I divide by 5 factorial, I could just think these 5's cancel, and I'm still left with that 9, 8, 7, 6. Okay, and that's easier to do. Okay, so if you're given something, I don't want to talk about it too long, but if you're given something like 13 times 12 factorial, one way you can simplify that, because 13 times 12 factorial means 13 times 12 times 11 times 10 times 9 times 8 all the way down. So 13 times 12 factorial is just 13 factorial. Okay, you can simplify it like that. You can just write the first number, okay, as long as they're all connected. Okay, so I'll show you why I'm talking about this when you can just type it into your calculator right now. Because what you're going to be seeing a lot more than just numbers probably, or at least just as much as numbers, you're going to be seeing variables. Okay, so you're going to be seeing things like n plus 3 factorial. Okay, now all of a sudden this looks much worse. Usually people start to not like this around now. Okay, don't panic. You can't type it into your calculator. That's the thing that sucks about it, right? It's harder because you can't just type it in. But it's the same concept. So if we're talking about n plus 3 factorial, all this means is we don't know what n is. Okay, first of all, n's always going to be a whole number. We're never going to be looking at decimals when we're talking about this. It's always going to be whole numbers. Okay, and we just don't know what it is. Like, it could be 5. If it was 5, right, this would be 5 plus 3 factorial. It would be 8 factorial, and that would be easy. Okay, but it's not. It's n, so we can't work with it. So if we want to expand this out, like if we want to do this like I did the 9 factorial earlier, where I wrote 9 times 8 times 7 times 6, what we would do is we'd start with n plus 3. That's the highest number. Now, from there, you always go 1 down, right? Like if I start with 9, the next number is 8. What's going to be the next number down from n plus 3? N plus 2. Someone said it, which is awesome. Okay? So the next number down is n plus 2. It's not 2. You can't jump all the way down to 2, unfortunately, right? Like, it's n plus 2. That's 1 lower than n plus 3. And then 1 lower than that would be n plus 1. Now, this sometimes is where it gets a little bit tricky. What's 1 less than n plus 1? And you could write n plus 0. It wouldn't just be 0, but you could write n plus 0, or you could just write n. Okay, like n is 1 less than n plus 1. And then if we go 1 less than n, what are we at? Not 0. Negative 1, minus 1, n minus 1. Like that. And then it goes n minus 2, n minus 3, n minus 4. Now, one of the things with this, since we don't know what n is, we don't know where this ends. Okay, we can't be like, oh, it's going to end at n minus 5. Because we don't know. We have no idea when this function is going to equal 1. Because usually with factorials, right, you start at whatever number you start at. Like if it was 50 factorial, you'd start at 50, and you'd go all the way down to 1. When it's n, we have no idea. So all you can kind of do is you can say it continues until 1. Okay, it keeps going down until it gets to 1. That's all you can say. Okay, so writing these out can be a little tricky for people. So let's just do like 1 or 2 more, and then we'll move on to what we're going to be working with. Okay. If I have n minus 4 factorial, and I wanted to expand it out into a multiplication, what would be the first factor in my multiplication? Just like here it was n plus 3 in the top one, what would it be with n minus 4 factorial? N minus 4. Okay, then what would the next one be? Would it be n minus 3? It is n minus 5. Yeah, I heard someone say it, but we're all very shy. Okay, it's n minus 5 and then n minus 6. So make sure that you're going all the way down to 1. Okay, and you don't need, there's no set number of these that you have to write. Okay, it's just understanding that it's going downwards. Okay, so what I see a lot is people accidentally going upwards, especially when it's negatives, because negatives, you know, they're confusing. Everyone knows negatives are confusing. You've probably known it since they were taught to you in grade 7, so or whenever you learn them. So here's same thing. Negative 4, negative 5 is lower than negative 4. So we want to go that direction. We want to go down. Okay, so this is how you do this. If I start with n, that's the only other one I'll do, just to be clear. If I start with n factorial, it's n, then n minus 1, then n minus 2, and so forth, all the way down till 1. Okay? So I know this doesn't look great right now, but let's try a couple examples you'll be asked to do with it. Okay, you're going to be asked to simplify things. There's only really 2 things you're going to be asked to do. One of them is to simplify. So up at the top it says simplify, where n, then there's this weird little shape, n. Does anyone know what this means? In particular, if you took 20-1, I mean, really, if you take 20-2 or 20-1, you would have seen something at least pretty similar to this. But in 20-1, you see quite a lot of it. Okay, this means that weird little E shape. Does anyone know what that means? Element. So this means that n is an element of the set of, and that n means natural numbers. So natural numbers are numbers that are whole and higher than that are higher than 0. So it's 1, 2, 3, 4, 5, 6, 7. Okay, so those are the natural numbers. So that top part doesn't really matter, other than to tell you that your answer would never, or the n would never be a decimal. Okay, so when I'm trying to simplify something like a here, okay, a is just like that example I showed you on the last page, but it's with variables. So remember on the last page I told you that 13, this is just an example to kind of try to make it clearer, that 13 times 12 factorial is 13 factorial. So knowing that, having that information, what could n plus 3 times n plus 2 factorial be simplified to? N plus 3 factorial. Okay, that's it. That's all it wants. It just wants you to know, well, since it's just one higher, I can turn it into one single factorial. That's all it wants, is for you to simplify it. Simplifying math means write more simply. Okay, it's not going to mean expand it out, because that expansion is certainly not more simple, right? That long thing, that is not simplifying. Okay, now B here is just like those other ones I was showing you, like where you had 10 factorial divided by 6 factorial or something, and a bunch of it cancels. This is the same. Now, this is how I actually do them. I will show you how I do these. I mean, I've gotten to a point where I can skip some steps, but I will show you my thought process when I do these. So my thought process when I do these ones, I'm actually going to lift this up so I can have more work room. Okay, my thought process when I do these, this one's n plus 1. Ooh, it's ugly. Okay, n plus 1 factorial over n minus 1 factorial. What I do is I expand both the top and the bottom. Sometimes people don't really like doing that because it seems like work, and I guess it is. But, you know, sometimes we have to do work in life. So n plus 1 factorial, like I talked about on the last page, is n plus 1. Then what's 1 lower than n plus 1? N, so I put n. Then what's 1 lower than n? N minus 1. And once I get to the thing that's on the bottom, I usually stop. Okay? And I'm like, I know from there, it goes to 1. Okay? On the bottom, it's like n minus 1. And I could keep going. I could write n minus 2 if I wanted, right? You could write as many or as few as you want. But the point is that it's going down to 1. So what's going to be on the top and the bottom that could cancel off? N minus 1 and everything beyond it. That's the important thing to understand, is that it's not just the n minus 1 that cancels. It's like n minus 1 and down is going to cancel. So n minus 1 all the way to 1 and n minus 1 all the way to 1 are going to cancel. So what I'll have left is just n plus 1 and n. Now, usually at this point, you're kind of expected to expand it and simplify. If I expand this, just doing a simple multiplication, so n times n, 1 times n. This part gives people trouble too, because sometimes people aren't great at this sort of algebra. What's n times n? N squared. And 1 times n is just n. So it simplifies to n squared plus n. If you were thinking it was 2n, that's, you know, it's not correct, but it's not the end of the world. But please try to remember that n times n is n squared, not 2n. Okay, and that would be your answer. So this is a little bit more complicated than the numbers, obviously. I'm just going to show you one more, because the other question you're going to be asked is to solve an equation. And again, here you'll see this thing where n is an element of the natural numbers. That's just, again, telling you n has to be a whole number and a positive whole number. So if you get a negative or a decimal, you either did it wrong or that's just not. Sometimes we end up with what we call extraneous solutions, which means solutions that don't count. Okay? Now, some people might be able to look at this, the n factorial over n minus 2 factorial, and know right away what would cancel and what would be left. Okay? There are probably people in this room who can do that. If that's you, cool, do it. Okay? But a lot of you are going to have to expand it out and show what cancels. Okay? So if that's you, that's completely fine. So always expand if that's what you have to do. So n factorial, I start at n, and then I always go 1 lower. So 1 lower than n is n minus 1, then n minus 2. Okay, and it keeps going. I don't like the way I had that there. And oh my god, it's even worse. Look at that. And minus 2 all the way down to 1. Okay? And on the bottom, n minus 2 factorial is also n minus 2 down to 1. Okay? And see, I didn't even bother writing anything in between them. Like, because I know it's just going to keep getting lower. Okay? And from there, I can, you should always keep your equal sign. So be a good math student. Always keep your equal sign and keep the stuff on both sides of it. Okay, From there, I can cancel this. This is where people, I lose people often, so keep track here. I have n. Actually, I'm going to write it in black. I don't like red. Okay, n minus 1 equals 90. Now, to solve this equation, we have to do quadratics. Okay, so if we expand this out, okay, and we get n squared minus n equals 90, this is what we call a quadratic equation. Everyone in this room did this in grade 11. Whether you did 20-1 or 20-2, you got to enjoy quadratics. So you're expected to be able to solve them. Okay, there's more than one option of how to do it. I will show you both of them. Okay, there is the by hand way, and then there's the using the calculator way. Whichever way you choose, you have to make sure you can do it and that you feel comfortable with it. Okay, so either way, before we keep going, you have to get everything to one side of the equation. So to get everything to one side of the equation, I would subtract 90 from both sides. So minus 90 minus 90. So it's n squared minus n minus 90 equals 0. Now, if you're doing, this is honestly because the answers are always whole numbers. The way they expect you to solve these problems, the way that they were designed to be solved, is by factoring. Generally speaking, people in 30-2 are horrendously bad at factoring. It's usually how you got here, is that factoring was really hard when you first learned it. But there's sometimes a few people in the room who do like it, so I'll go over it briefly, and then we'll talk about how to do it on your calculator. Okay, so the rule for factoring is that you're trying to find two numbers that multiply to the last number and add to the middle number. So here I'm looking for two numbers that multiply to negative 90 and add to negative 1. Okay, because it's negative n, which is the same as negative 1. So I'm looking for two numbers that when I multiply them can make 90, negative 90, and when they add up, they make 1, or negative 1. So what would those two numbers be? Negative 10 and plus 9. Okay, so it's negative 10 and 9, negative 10 and 9. They have to be the same two numbers, right? You can't be like, well, like 9 and 10 make 90, and then 8 and 7 make 1. You can't do that. You have to pick the same two numbers. It's negative 10 and 9. So that means my factored form is n minus 10, n plus 9. Not that hard, right? It's not too bad. Now the answer from there is, this is the part that kind of mixes people up sometimes, is the opposite. So if my factor is n minus 10, my answer is n equals positive 10. And if I have positive 9, the answer is negative 9. Now at the beginning though, I told you the answers here can't be negatives. So that negative 9 is actually considered an extraneous solution and is not counted. You would need to make it obvious to me on a test that you know that that answer is no good. Okay? By crossing it off the way I just did, or writing extraneous next to it, or whatever you have to do. But you would be expected to show me that the answer is no good. So I think the answer is 10. So one way to check that is you go up to the top and you just plug 10 in. If I do 10 factorial over 10 minus 2 factorial, if I type that into a calculator, what do you suspect I'll get? 90. And as long as you do, it means it's correct. I'm pretty confident in our abilities here.